Hello everyone. In this video, I'm going to go over factoring trinomials, in particular with an a equal to 1. Now, a trinomial we define as anything in the form, as an expression anyway, anything in the form ax squared plus bx plus c, where a, b, and c are going to be integers. And so there's two types. This type that I'm doing in this video is when a is equal to positive 1. So my leading coefficient is going to be positive 1. Now, b and c can be anything they want. And we're, of course, going to be looking at numbers that you actually can factor. So now there's a broad range of trinomials, most of which you can't factor. Of course, I'm only focusing on the ones that you can. So briefly, there's two steps you want to look out for, and they are, first thing is look for a GCF, a greatest common factor if there is one. And then second, identify the trinomial, meaning that you want to make sure if it's the type that I'm going over right now or the type that I'll do in a different video where the leading coefficient is not positive 1. So of course, in this one, we're doing our basic form where it's equal to positive 1. Most of this, I'll show you an algorithm to follow, but most of it's more of understanding your times tables. I tell my students that for these kinds of problems, the best thing you can really do is know your multiplication tables. I always advise know at least through 12. The more you can do that mentally, the faster these go. But let's do an example. Let's say x squared minus 7x minus 30. And our question is to factor. So we're going to look at two numbers here. So I've got my 30 and then my negative 7. We want two numbers such that the same numbers can multiply to get a negative 30 and can combine, meaning add, to get a negative 7. And here again, the more you can do in yourself mentally, or you can work with mentally, the easier this becomes. But as a general way of approaching this, let's stick to the negative 30. What are our factors of 30? Well, we have, of course, 1 and 30. I have 2 and 15, 3 and 10. 4 doesn't go in there. 5 does, 5 and 6, which is the same as 6 and 5. So I'm not even going to bother with that one because the order isn't critical with this. So of these three, or of these four, we want to say which of these can in some way combine to get a 7. And as I said, it doesn't matter what order you go in. Also, when it comes to these factors, what I tend to do is, you saw I go in numerical order, 1, 2, 3, 5. I just keep going down, starting at 1 and seeing if 30 has a factor with the subsequent numbers. So 2 does, 3 does, 4 does not. There's no 4. 4 does not go into 30 evenly, and so on. And if I were to go beyond 5, you said, what about 10? I'm going to start repeating what I have, so that's why I stopped. And so this is a matter if we can see that 3 and 10 could definitely, let me change that color so it doesn't blend in too much. 3 and 10 can definitely multiply to 30 and can get negative 7, but to get negative 7, for example, we need a negative 10, and therefore we can also make a negative 10 for negative 30, and it still works out. So by consequence of this, our two factors our two terms, I should say, are negative 10 and 3. So in this format, ax squared plus bx plus c, our solution is always going to be in the form of two binomials. So right from the start, I already know this is going to be x, this is going to be x, just because the variable is x. And then just put in the numbers. So negative 10, positive 3. Positive because there's There's no negative in front of the 3, so we can assume positive. And the order does not matter, so I could have put 3 on the left and negative 10 on the right. Still the same answer. And we are done. This would be our answer. Now in this one, I had no GCF. In other words, there's nothing divided into any of these numbers evenly. So I just go straight to the trinomial. And this is the way we do any trinomial. Let's try another example. I'm going to do x squared minus 9x plus 18. Again, we're just factoring that. So I'm not solving, I'm just factoring. There's no number that divides into any of these, 9, 18. And remember, if we don't see anything, we assume we have a 1 in front of the x. So I still have a positive 1 there. So I can't factor anything out, but what I can do is then say, let me go to my terms. I need something that can, let me try to be consistent, that can multiply to a positive 18, and the same two numbers can add or combine in some way to get a negative 9. So go through what are our factors of 18. Always have 1 and 18. It's even, so we know 2 will go into it. 2 and 9, 3 and 6. And beyond this, I start repeating myself. So which one of these could conceivably add to a negative 9 in some way? That's only possible way you could do that is with a 3 and a 6. And 3 and 6, 3 and 6. The only way that's going to happen is if they're both negative. And if they're both negative, that will still work for 18 because negative 3 times negative 6 is a positive 18. So I found my factors. I know because it's a trinomial, I can automatically set this up, x and x. I just need to put them in, negative 3, negative 6, and we are good. Nothing else needs to be done. One thing to also notice between this one and the last one, notice with, let me try to draw some attention here. Notice with I have a negative here and a positive here. As a general rule, a little shortcut, and there are a lot of little shortcuts, I tend to advise the best way of getting through these is don't rely too much on short little tricks. The more you know the math, the easier it'll become. But one thing you can look out for is whenever I have a positive sign at the end here, so plus 18, whenever that's positive, there's only two choices then. That means that means both of these terms are either going to be positive or they're both going to be negative. So in this case, they're both negative. And that's pretty obvious because we have to have a negative middle term. So it only makes sense that they're negative. So that's something you can use just to confirm what you might be finding. So again, if there's a plus sign at the end, that means in our two factors here, they're going to have the same sign. They're both going to be negative or they're both going to be positive. And you can usually figure it out based on what the problem gives you. Compare that to my first one. And notice here, now I have a negative at the end. The difference is when there's a negative at the end, you have your answer is going to have one positive and one negative term. It's the only way it's going to work out. So if you have a negative at the end, your solution is going to have one positive, one negative. And another way of just verifying that you have the right setup is, in this case, my 10 is negative. Notice that go by the middle term again. The middle term is negative from the start. And then another little trick you can do is once you have your two terms, if, for example, you might be having trouble figuring out which one's negative, which one's positive, a little trick you can do is go by the sign in the original. The middle sign here is negative. So that means which among these two numbers, 3 or 10. Which one of those is its absolute value is bigger, I should say. Is the absolute value of 10 or 3 bigger? And of course, it's going to be 10. It's bigger. So the larger number, or the number with the larger absolute value, gets the same sign that's in the middle here. So negatives, therefore negative goes to the 10. And obviously then the opposite sign goes to the 3. So again, if you have a negative at the end, once you find your factors, the larger of the two gets the same sign as the middle term. It's a little trick you can use just to verify that you're on the right track. Let's try one more. I'm going to say 2x squared minus 14x minus 60. Again, my question is to factor. Now, one thing hopefully you noticed is that each one of these terms is even, which means they have a GCF. I could factor at least a 2 out. Let's see what that gives me. If I divide each of these by 2, I'll get x squared minus 7x minus 30. That should look familiar. And since I factored out my GCF, I must put it on the outside. Your GCF should always be the first step. Now, the previous two did not have them, so I didn't have to bother with them. But this one did, so it must be the first thing that I do, or else other problems are going to be very difficult. Now that I factor that out, I can factor the remaining trinomial just as is. And that's the same as the original up here. So we'll just do a fast track. And this is going to be x minus 10, x plus 3. And don't forget, if you put x plus 3 first, it's fine. The order is not critical here. As long as you have all 3 points, or all 3 parts, I should say. The GCF on the outside, and then my 2 binomials on the right next to them. So remember, when it comes to factoring trinomials, when your leading coefficient is positive 1, look for a GCF first, and then it's a matter of what can multiply to the last number and add to the middle number. Then you might be saying, well, wait, the last one didn't have 1 as the a value. And that's true, but that usually applies after we take the GCF. And that's why I say that's the first thing you should do is the GCF. Always look for that first, because that will help you distinguish between ones that you can just factor out a GCF and still do our basic factoring, or ones that are more complex. So I hope this helps you in your math endeavors. If you have other problems you want me to do, please submit them, and have a good day.